I first want to say thank you guys for joining the webinar and coming to this product information. If you don't know about the antennas, please feel free to have questions. If you have questions, you can leave them in the chat. Well, I'm sure that we'll do a Q&A after. But if you have something that you want to know kind of immediately, please feel free to put in the chat. We'll have Alejandra. She'll be checking the chat and making sure questions either get answered to her knowledge, and or we'll revisit them at the end of the presentation. We also have Mr. Diaz. He's going to be in the background, and I'm sure if he has anything that he wants to, some feedback he wants to put into the presentation, you'll hear from him as well. So the first thing we want to do is we're going to be talking about our wireless setups, which are as you can see, the P2P-X 150 and 900, and what how we normally use them and what applications do we use them with. We're going to go over our dip switches and dip switch technology so that you can understand how they work and what happens kind of in the background of our antennas. As we said in the beginning, we'll be covering the actual antennas themselves, which is the P2P-X 150 900. Then we'll go over the installation and angles, which is very important because a lot of times we get some individuals that may not know about the degrees and angles and gains behind that. So we want to cover all that to make sure everything is going to be understood and known. So again, please feel free to use the chat or have questions, and we'll answer them at the end of the presentation. Okay, so first we're going to talk about dip switches, okay, and the technology behind it. It's going to be an actual type of unit here that you'll see that's going to be located on the antenna itself. And what that's going to do for you is going to give you the ability to not use computers or have any networking experience. You'll just be able to flip that switch on and then pretty much set it and forget it. So that's just going to translate to easy deployment. So if you have individuals that work for you or you want them out in the field, they don't necessarily have network experience or ever worked with maybe a network product. Now, if they're here, we can easily give them information on how to use this and then get those deployments out in the open. Now, I just want to let everyone know that these antennas are specifically and specialized to be used with cameras. Okay, there is some APs that specialize in the network side, but we use them for CCTV for the things that we actually sell. And what is a dip switch? So the dip switch is pretty much going to be a little switch that works behind the scenes with a chipset or algorithm that's going to be IP based. In this situation, you'll be using the dip switch to find your frequency. You'll be for your selection on when your multi-points or points to points, and that's what's going to be happening in the background for the dip switch itself. Now, how does it work? This is going to be some of the main important information that you'll probably be viewing to get started with the antennas. As you can see where it says AP and CPE, if you look to the right of that and some of that verbiage there, you'll see that the button number 1, we want that in the up position. The reason why we want that in the up position is because we're going to be using that to receive all the data from any other, I guess you can say CPE or client to get that information or camera feedback. And to use on the other side, where it says 2 through 8, that's going to be your frequency selection or pretty much a different segment. That's going to be used with, say, if you have more than one set of multi-points, we're going to start making a selection based on the 2 through 8. So you can have up to 8 multi-points in one system. The 9 and 10 are going to be your selectors. And what that is really kind of meaning is if you have one point to point and you have multiple antennas, you'll put 9 up, you'll put 10 up, leave 9 down, put 10 up, and so on. We'll cover that in the next slide, but this is just the basis of how everything's run. Just remember to have that AP in the up position, and so that way you don't get confused and the system will work properly. So what we mean by multi-point or point-to-point is going to be this example here. You'll see that this is up and all the rest are down. So if this was just going to be one set, then this would be all you need to do. Oh, I'm so sorry. You just would need to do from here to here. That would be your point to point. Now, if you needed to do, say you wanted to use 2 to 1 access point, then what we would do is we would go here, push 9 up, and then now we're still communicating maybe 1 or 2 buildings to your access point. And again, the same thing happens to the next one. We're going to move 10 up instead of 9 because we already have 9 up. That's going to generate 3 buildings to 1. And then this one here is going to be 9 and 10 up. And that's going to give us 4 to 1, which is the max at the moment. So we'll be maxed out with 4 clients to 1 access point. Okay. Now, again, if you wanted to use a different set, say this was we're already maxed out here, but we had maybe, 4 more buildings and we needed to get that information over to the main building, we would just put 2 up and we would put 2 up on this one and so on and so on and so on, using the same selector information on the same now new frequency. Well, first, we're going to talk about the P2PX, which is commonly used in our solar solutions. Our solar solutions are the TSB35, which is a single panel solar solution, and we'll also have the SB80, which is a dual solution. We'll be having that, I think, next week. So you'll learn about the solutions and all the different configurations that we have for those solutions to work. But at this moment, we're going to go with the TD-P2PX, and that little guy is actually going to look like this right here. And let me see if I can get us back on the screen. And this is going to be the P2P150. This is what it's going to look like in the back. It's actually going to have 12 volts that you can connect directly to your solar solution, is what we were saying is commonly used for. So it's 12 volts directly into the antenna. And you can also use 24 volt PoE, which you'll find here. That will go into a different, as you use the PoE injector, then you can connect it to an uplink and get that information that way. So the transmission range actually is 1 kilometer. So it's going to be about under, let's say, a mile or so. That's pretty good distance, regulated distance for CCTV. And 150 megabytes worth of transmission. So if you say, hey, I want to have about 5 cameras using H.265, then you know that we don't want to go past a threshold of 150 megabytes per second. It is solar solution ready. As you saw, the 12 volt connection will help you do that. So when we say point to point, or we're going to use antennas, if you look at the diagram, you'll see that there is the green building, which we'll call, building G, to the purple building, which would be, we'll call it building P. So as you can see, as long as we have a site where this is going to be in range and also it's going to be looking directly at the camera, we want to keep those, looking directly at the antenna. We want to make sure that we keep that within a 60-degree angle from each other. We want it to be pretty much clear. We do understand that there is some obstruction sometimes, but the clearer the better, and you want that strong signal so you're not dropping cameras. Okay, so that was pretty much easy for the 150. Here's for the P2PX, but here's a 150. And this one is what we want to use for greater transmission, maybe something with 4 megapixels or higher because of the gain. The gains on here, since it's a larger unit, it's going to use a 48 volt injector or a 48 volt PoE. We'll get a little bit more out of this one, okay? It's not small, and it's not going to be it's not going to be used for most of our solar solutions. This is going to be strictly for building to building, or for long range purposes. Okay, so it's going to be 1.4 kilometers. So it's about a mile. It's going to give you a lot more coverage, and still 150 megabytes, but since it's going to have a little bit more transmission speeds, and the memory, as you can see, it's DDR2 with 64 megabytes worth of memory. We can push a little bit more signal. So that's where you're going to get your differences. And the 10100 megabytes is pretty much the normal speeds that you'll see on a router or on a switch, and how that's delivered. So we do have a more robust unit, which is going to be the 900s, but of course we'll get into that in just a few. So the PoE is going to be 48 volts, which is most of the PoEs that we're going to be using for this unit. I would recommend the PoE Plus, because a lot of times you're going to use so much more power with cameras that may have fluctuation. When I say fluctuation, I mean going from IRs at night, and then back to regular, just color picture in the daytime. The transmission for DSSS, that's just a regulated speed, a spectrum style of speed that these antennas use. That way you can get the distance that you need, and the speeds that you need to deliver crisp, clear, and clean images. We want to just keep in mind that we're going to jump into H.265. I want everyone to remember or think about that. So I'm going to say it quite a bit, as H.265 is going to give you the ability to put more cameras onto these units and use them with more of your commercial settings, because there's going to be people that want 24 cameras, some people want 32, 64, and at this moment we do have clients that are using them in those kind of settings. If we're going to use the more cameras that we want to use, of course we want to go up in style or up in the product. So that what I mean by that is going from X to 150 to 900. 900 is going to give you all the power that you need to deliver multiple cameras. So here you'll see where we were talking about multi-point, right? So it's just pretty much getting one area to deliver a camera or deliver a signal to a central area. All of our P2P systems can actually do that. We can use multiple ones in one setting. Of course, again, H.265 is going to be your go-to, and knowing exactly by using actually, I'll show you a disk calculator. That way you can learn and know what you can do as far as bit rate's concerned, frames per second, and move forward from there. So I really don't think that I have to read everything for you guys. So I want to just kind of see if you guys have any questions so far. If not, great. But I want to give a chance to, for some of those questions to develop. And if we have anything that we want to ask now, then, let's go ahead and see where we are and what you guys understand, if we're clear, or if I need to slow down or speed up. Just want to be a good host for today. So do we have any questions so far?
I think you're doing amazing, Terry. Thank you. I don't see any questions on the chat. If you guys want to type your questions in there, or if you want to unmute yourself for a second and ask Terry any questions.
All right. Well, it seems like everybody's doing good, and everybody's understanding what's going on. So I guess I'll continue to move on, and we'll go to the next deal. Well, here is going to be pretty much, I wanted to have this slide in there. I wasn't going to actually add it, but I thought it would be some good information, because I was going to say H.265 probably 100 times. So this is why I decided to add this in. So let's take a look at the H.264 video compression, and you'll see that the bandwidth is actually going to be a lot higher. I mean, for a 720p camera, we have it from 1 to 3 megabytes of bandwidth that's going across that antenna. Now, if you jump down to 1080p, it's already 3 to 8, so megabytes per second. So we'll be using a lot less cameras and a lot more bandwidth by using H.264. And if you go and look on the other side there where it says H.260 video compression, and we're looking at 1080p pretty much right from the start. And that's going to be 1 to 4 megabytes. So that's pretty much cutting it in half. And where we would use maybe 2 cameras, now we're going to be using 4 in that situation, or 5, depending on how we change our frame rate and if we change our frames per second. And we'll go down to 2K, and which is your 4 megapixel, and it's 2 to 7. Over here was already 5 to 15. So we're already pretty much maxing out on the P2PX and the P2P150 when we're using about 2 cameras on a multi-point, or about 4 to 5 cameras in a point-to-point setting. The 4K, 6 to 18, I mean, over there from 11 to 35, we're pretty much saying we would only use 1 camera per 150 megabyte unit. And I mean, we probably would try to figure out a way where we would want to use more cameras. So with H.265, that's now something that you can do. And also remember from our previous webinars or presentations, we now have AI coding. Now, AI coding is going to give you a lot more compression, because now you are having our systems do something in the background, or looking at the target instead of looking at a full frame and moving those full frames. What's going to happen in the background is that the frames that's being targeted will move, but everything else in the back will stay still. So then you'll just see that target moving. That's going to give you a lot more compression too. But again, this is all based on using the calculation tool, also decreasing and increasing some of the frames per second, and also the bit rate. That will give you a little bit more room to play. We'll get into that a little bit later, and I'll show you that. We'll jump from one screen to another, and hopefully you guys will understand that. And if you have questions, again, please feel free. Okay, so here we go with pretty much a little idea. I'm going to move something real fast. And this is where we were saying about how many cameras, more or less, that you can use. So using H.265, you'll see, all right, well, before we could only use about 3 cameras. And this is just a rough estimate here. I wanted to kind of keep it on the lower side and not max out, because we wouldn't want anyone to say, hey, you told me we could use 12 cameras and you kind of maxed out. So we'll start here, and then can gradually, once we start learning how to use the tools and you feel comfortable in your installation, you can move up your camera usage if you like. But let's leave it here at the basis. So we don't want to max out. We don't want to use all the pretty much bandwidth and data of the point to point, because what's gonna happen there is you're probably gonna get a lot of dropped cameras, and we don't want any of that. So leave a little bit of room, so for fluctuation, no matter what you're gonna do. If you're gonna try and connect it to the actual PoE switch, I recommend using an ejector with it, but you can do either one. So here, actually, let me see if I can move over to the disk calculator so we can take a look and see. So can everybody see this disk calculator clearly?
No, I don't think we see it. It just kind of like removed the whole screen, and there we see the presentation, but I don't think we see the calculator.
Okay, well, let me see. I'll see if I can move it over. Okay, here we go. Let's see. How about now? Okay, yeah. Great. Okay, so this is a good tool. You can actually go to our website and download this tool. It's going to be good for usages with hard drive space. How do you want to set your cameras up when you're kind of bandwidth limited? In some areas where the network may not be as strong, you can use this to kind of figure out how how you can go about making some changes or adaptations to a network. Well, so what we're going to do is we're going to stick with this, what we have right now, and then show you how things can go. So before we start, I want you to take a look right here where my mouse is, and that says kilobytes per second. So it's going to be pretty much, I think it's what, 1,000 kilobytes to 1 megabyte. So we would need to translate that to 20,000 so we can make a division. But let's go here. So we'll have one camera at H.265, 4 megapixel at 30 frames. So this is going to be your bit rate. What we would do is we would take that and divide that by 20,000, and then we'll get a number. That number would then give us an idea of where we are on our megabytes per second. So if we're going to use 2 cameras and we want to see, oh, not that many, that's not going to happen. Well, we can start, analyzing, what we're going to do if we're going to use audio, if we want to change the frame rate. Excuse me, move this back to 1. We're going to use 8 megapixels. How much is going to be right here? So then that gives an idea how we want to adjust and use the camera. So we want to go to 10. You see that it changes, and that will help with delivering that data across your antenna. Oh, what happened there? So I stopped screen sharing there. Sorry about that.
Yes.
Okay, how about now? Looks good?
You're good.
Awesome, thank you. Okay, so that was going to be for that one, and this is going to be for your multi-point. So for the multi-point side, it's going to be just a little bit different because we're going to now, instead of having everything concentrated on one antenna, we can now use multiple antennas to deliver a couple of more cameras. And now altogether, we're just going to be worried about our access point. So we don't want to max out our access point again. We want to keep it up to 35 megabytes per second if we're going to be using, because of bandwidth. Now, again, where we used to be able to use 2 per, now we can do 4. And I think we could even do a little bit more than that. But again, we have to go back to our calculator and look at it and make sure that we're using it properly. But at least from a 150, you can do 4 to 5 cameras on one access point or one client to get that back to your DVR. So right here, if you're using a 16 channel, unit, now you can get that information over there, no problem. All right, so now we'll jump into the TDP2P 900. And I feel that this is, it's greatly used for cameras, but it does so much more because it's just more robust, period, okay? So you can use this with network transmission, and we've done it here, and we have a couple of clients actually give us some feedback on that. Again, we do state that this is for CCTV purpose, but you can use it for networking, okay? If you wanted to use a small little area, say maybe from a house to a pool house, you can do that. Just remember, it's 900 megabytes per second, and if that's what's going to be traveling, I think most network speeds are probably up to 300, 350, unless you're using fiber. So just keep in mind what we're going to be using and the speeds that you're looking for when you're using something like this for networking. Again, it is for CCTV. How does that look? Well, this is how it's going to look from here. So in the diagram, you'll see that you'll have, the internet or modem, and you want to, you want to shoot that signal and your cameras over, to a different area or receive that information. So this is how you'll see it. You'll have this connected, and then you'll have that, you put your dip switch up, keep your dip switches proper, and bring it over to the other side. Now it's not a Wi-Fi unit, okay? So keep in mind, you will not see a broadcast coming off of there. It's going to be all pretty much passive data. So you will need to have an indoor router or an access point, something that will broadcast for you on the other end. Or if you just needed to plug your computer directly into that landline, you could do that as well, and you would get that internet from over there. I would recommend using a router on the other side. That way, if you wanted to use, have multiple users, then you could, and that would just give you better usage out of the antenna than just kind of directing it into one system or one device only. Now it does have a really high gain, and what that high gain is going to mean is pretty much the distance and the strength that signal is going to be coming at you. So here on our, excuse me, our antenna gain is going to be 16 dBIs, and that's going to, at the bottom, you'll see where it says miles. And of course, we want it to be, thank you, welcome. We just had another, an individual come in, so thank you for showing up. Really appreciate it. It says 0 to 80 miles when it comes to the dBi. Now, I think when they did this calculation, they probably were in space where there's not going to be any trees or any diffraction. Yes, but they definitely do have a long signal. The degrees that you see attached to those dBi is very important as well. You'll see 60, you'll see 30, because the lower the dBi, the signal is going to be a little bit, it's not going to go as far, so it's a lot wider. And just like a telegraphic lens, you have a motorized lens. The 2.8 lens is going to give you a wider area, and 3.6, and then when you get to 5, you get a tighter angle because you're actually going further. So that's going to be the same concept when you're using data and this setting. So it is up to 2.4 kilometers, if I'm not mistaken. That's about 1.5 miles, maybe a little bit more or a little bit less. And it's going to range the speeds that you're going to get across pretty much a network or router or switch. You can see that it's 10, 100, 1000, which is a lot better than the 150. And again, I mean, this is going to be the high end of our antennas. So when you're having a high end project, this is what you want to, this should be your go-to, right out the gate. Don't think about the 150s, don't think about anything else. If you got a high end, keep this going so you don't have to come back and your customer be happy, you'll be happy, and time is money. So we want you guys to make sure you use the greatest equipment that we have to offer when it comes to high end stuff. It is going to be PoE 48, so it's going to use the same voltage that most of your cameras use. And again, I would recommend using an injector, but you can use it with your switch if you choose to. If you're going to use it on your switch, just remember that 30% rule. Don't cap out, because once we start using a lot of data and then the fluctuation, you can get some dropped information there. I'm not sure, but I hear a little bit of feedback. Was there a question? I don't want to.
No, Terry, I'm sorry. That was me. Can you help us mute? I wish I could help you mute people in here, but I can't. I think
no, that's okay.
Looks like somebody's got their mics on.
Yeah, I just wanted to make sure that no one had a question or if there was anything that.
Awesome, super.
Oh, one second, please. Sorry about that. Had a little technical difficulty there. Make sure that everything was still working and couldn't hear anything. But thank you guys for your patience. I do appreciate it. So where we were at, we were on 48 volts, and we are talking about fluctuation and how we want to minimize that. So we want to make sure that if you're going to use a PoE switch, make sure it's PoE plus. I do recommend that. And if you want to just stay away from troubles completely, get you an injector, use the uplink side to the LAN of that injector, and use the PoE side directly to your unit. And you should see a lot more that you'll get out of that unit. Okay, so here is a look at the 900. Where there's I mean, it may look the same, but you'll see that there is just a little bit difference in numbers. So where the bandwidth was at 50, we are now moving into 100. So that's going to give us way more ability to transfer data or camera images from one place to another. If you look right there, I mean, we're saying at 1080. Of course, we can use more, but now you guys know how to use the disk calculator or calculations from that feedback of information off of that disk calculator to what we can and can't use. So I had to use that calculator right then, and then I was going to try and put a lot of cameras there, but I was going to run out of space. So I put the plus sign, and that should just give you an idea. With the 900s, any big project that you have, you're gonna do well. And again, like I said, I'll probably say H265 265 times because I wanted to stick with you guys. I want you to go into that encoding of that camera or the NVR and change those settings so you get the best out of your equipment, and you can use a little bit more equipment, because the more equipment you sell, the more equipment you'll make, I'm sure. And we want to see that. We want to see those pockets full. So again, that maxing up to about 70 megabytes is where you want to stay at, and you won't have any problems. So if there's any other deals, I mean, we kind of see from we learn from the 150s and the P2PX how this goes. So we don't have to spend too much time on it. But if you do have a question, if you feel like you want to have the illustration, you have something you have on your mind, please feel free and take that time right now before we start jumping into anything else. All right, great. Looks like everyone is comfortable and the message is getting across clear. So thank you again and for your patience and time. All right, so now we're going to get into the installation part. Okay, it's going to be we'll spend a little bit of time on it and go over it because it's very important. It will see, so you can see I put up a lot of images, a lot of pictures. I think it's like maybe about 3 or 4 slides that we'll go over, because we get a lot of people that they do put them up right, but they have a little bit of trouble. But before we do that, I actually wanted to show you guys an actual unit and kind of how easy it is to flip these dip switches. So this is actually the 900 that we just got through talking about. Now I have like a little screwdriver here, something that some people's fingers, or they don't have fingernails, and then they get to flipping these switches, and then they're not all the way flipped up, and then they'll put it up, and then they'll call us and say, hey, it's not working. So what I do is I grab a little tool, something that's easy to get in between there. I mean, so you know that you have the ability to pop that switch up and down with ease. So here you just pretty much down, and then what you want to do is you just really need to pop it up. Again, I even fat fingered it with a little screwdriver, but it happens. But you can get to it fairly easy. It's not going to be very hard. You can use on the 900s or the 150 that's this size, the 150 that's this size, you can actually have 2 ports. So you can use either one of those. You can use one of them to transmit data or plug directly into your computer, one that's going to be transmitting data. They do have 2. Now, on the 150, this one that we talked about earlier from the solar solution has the same deal. But this one, if you notice, only has one, sorry about that. This one only has one, so we'll be using this one pretty much to power and for data. So if you're going to use this one in a commercial or a residential home setting and not on a solar solution, then you would want to use an injector so you can use that land side. And again, these are all simple and easy to use, very, very, very easy. And like I said, you can set it and forget it. You don't have to have any network experience, and you're on with the next job. Okay, so here is, we're gonna say pretty much looking at a standalone system, say we're not gonna be on the network, we're gonna be just plugging this directly into the NVR. And the angle is really what we wanna talk about. That's the most important. This is just one type of illustration and installation that you can do with this system. So you'll have each camera, of course, in your isolated area or where you would like to have it placed. And then you'll make sure that that antenna is going to give you a 60 degrees. So if it looks a little bit off, please take some time to kind of just, get your hands out there, think of 60 degrees. And if you can see it, if it's in a line of sight, more than likely, you're going to be within that range. And if you're going to be a long way away, then make sure you get as tight as you can to the angle, because of course that it's going to travel, and we want to make sure that we're not going to miss it. The further you are away is as you can see at the bottom, the greater scope of coverage, and the smaller the angle, the further the transmission distance. So you got to make sure your angles are going to be pretty much in that 60-degree pocket. If you're going to be using one with a higher gain, as we saw in the previous slide, we want to make sure that we're going to be within that 30, 45 range to make sure that we're going to get that long distance if we're going to be using a longer transmission. Now, this is very, 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 very important. It's one of the slides that most people kind of overlook, and they tell us, hey, it works. That's not necessarily true. Well, it's not necessarily true until we start expanding. We start expanding and more data needs to travel and bandwidth gets a little bit higher. Well, as you can see, those three lines at the bottom with the green check mark, that would be a little bit different. So we want to make sure that this at the bottom with the check mark is happening regardless if we have one or two cameras. If we have one camera, we want to make sure that you're never going to have any points of failure at all. So please, right here where you see the blue X, just keep in mind that diffraction happens, and we know that signals bounce off of walls and trees and everything else. But the higher you place this to get that in the green check area, the better your installation will be. I'm sure if you guys use these before, you've come across some of those hard angles and hard installations, but we always overcome and we get these things done. But this is just a good illustration to make sure that everyone's on the same page. And again, angles and illustration and all that good stuff is very, very important. Now, this is going to be pretty much on your wall setting, like maybe from the ground up. We're not going to be having anything that's going to be obstructing. Say you may be in a building, and I'll say an apartment complex, for example, say on the side of the eave, and you're going to have this, have another one on the other side of the eave, and we want to make sure that it's going to be, pretty much site to site. The higher you place this antenna, the better. Diffraction is going to happen in this setting, and it may work because signals do bounce up and down. When I was in networking, we learned a lot about this same type of frequency system or waves that bounce from one area to the next. And where this may work, as you can see, the probability range is going to go down. So you'll have it working, you'll have the system working, it'll be working fine, but you won't get as many, you won't get as much out of the system as you actually can. So your potential goes down by far. But in some instances, you may need to use it at 10 feet. You may need to use it at 12 feet. So just keep that in mind. As long as that we acknowledge what's happening, and then we can go, and if we have to troubleshoot, we know exactly what to do and where to start that troubleshooting method. And I think, at this time, it's probably about to 12:45. So I just want to kind of finish up and get everybody's input, feedback. Where do you see this being implemented? Because honestly, your feedback helps us all grow, and where we can use this and have different ways to implement it. We want to hear that from you right about now. And again, I do appreciate you guys showing up and um, and being part of the webinar. Oh, please, if you can, leave some information, maybe a name in the chat. We should have most of this stuff blasted out to you via email, but in order for us to be efficient, if you could leave your name, maybe an email in the chat area, so that we can reach out to you and make sure you get your CU credits. We want everybody to get what they well deserve, and thank you for your time. We really do appreciate it here at Tough Dog.
Thank you so much, Terry. I love your presentation. I just wanted to mention something for a quick, like a situation that I had with a customer. They're going to be using several point to multi-points. And so just wanted, like, I think it's something good to let them know that if they're going to have several multi-points, they just have to separate them between like 6 feet, is it right? Like each from each other?
Correct. So what they want to do is see the frequency as well. So I'll just jump back to the slide that we talked about, and the frequency is going to help with that. And because we're going to say, hey, we're going to get a different frequency, but yes, we want them to definitely be a little bit at a distance, because once you start getting that white noise, sometimes that can cause a little bit of disturbance in one unit or another. So, but make sure that they understand the difference between the frequency setting, which is from 2 to 8. Keep that in mind, and maybe if they need to be a little bit closer, a little bit further, then we use maybe a frequency that's on a higher level by maybe using 8 instead of 2, or so on and so on.